Um, we will do an example circular motion problem. So here is this is a horizontal table, horizontal, we'll say frictionless table, and we have a block A, another block B. They're connected by a string. The string goes through a hole in the table. This is a hole in the table, and if you make this block A go at a particular speed in a uniform circular motion, then the whole thing of B will just stay put. The acceleration of B will be 0. That's what it means, stay put. And that's the problem. And it turns out that this critical velocity with which this should be going around is actually related to just the radius of the circle, this gravitation constant, its acceleration to gravity, and the ratio of the two masses. So I want you to work on this. Maybe you can pause the video, because I'll work for it, and then maybe you can get the answer. If not, then you can come back to the video and restart it. Okay, so all right, let's see how I'm gonna do it. Okay, so what I would do it is have a F equals ma for this and Fn equals ma for that, and then I'll examine those two F equals ma equations and see if we can come to some conclusion, can work with it. So this appears to be a simple one to work. So let's start with here. I know we want to answer over here, but the two are related through this tension force. So these two tensions are equal in magnitude. This tension is vertical, this tension is horizontal, but their magnitudes are equal. So let's see if we can work with this guy first. So if I look at MB, this is, the tension is up this way, and its weight MBG is that way, and acceleration is 0. That means you can right away, you don't have to axis or anything, they're in the same direction. Right away you can tell that T minus MBG is 0. T minus MBG is 0. So the tension is equal to MBG. Alright? So that's one thing we can do right away. When we look at block A, it's going in a circular motion, and it's uniform circular motion. And so so block A is in uniform circular motion. Well, that means we know the acceleration for the block. That means the acceleration is centripetal. Centripetal. And that's all. There's no other acceleration. So that means that if I look at what's going from block to the center of the circle, so if this is going a circle like this, from this block and this to the center, acceleration is pointed that way. So then all the forces add up so that in that direction is 0. That direction is equal to mass times acceleration. Well, what are the forces on it? Well, you could look at the block. There is a gravity down. Gravity is down, which is about 90 degrees. This is not going to have MAG, does not contribute to that acceleration. The normal is same way, doesn't contribute. And there's no friction. The only force in that direction is tension. So, and acceleration is that way. Acceleration is v squared over r. So when I write the equation along this direction, I get T equals to mass A AC, which is T equals to mv, and this is critical. That's the v is the critical velocity we want. So this is the equation for this. So if you look at equation 1 and 2, I can use the t from 1 in 2. So therefore I get mbg equals, this is ma v critical square over r. Well, I want this, so I need to isolate that, and so multiply by r divided by ma. So mbgr over ma, isolate v critical square, and I take a square root of this, and that's the answer. So v critical, and I take only positive because this is speed. So mb